Good night. So this will be a microscopic examination of material from the red clay pit that I have burned several times. You've seen it in various videos. So two samples were taken yesterday or the day before. I don't even remember. Maybe 2 days ago, before the last fire. But after several fires, these are the two, and two samples were taken just now. I have not watched it because I want to do it very quick. I don't have it, and I don't want to put too much effort to it now. So this will be very quick ones. We should also mention that this one, the new two, after electrolysis of some time. This electrolysis was done, with material that is very non-conductive, because it was mostly oil, but maybe some kind of of ionization could have taken place, and maybe you can see the result of the ionization. But let's start, with the two slides from before the electrolysis and the ionization, but after several fires. Again, this is taken without preliminary check. I don't know what we are going to actually see. And I'm going to do it quickly because, I want to concentrate on other things, but it should be done for documentation purposes. So I will not put too much effort on it, but just a quick review using 64 magnification. Looks like a huge Nero, or possibly something else, I don't know. This is interesting. We certainly see life forms here that survive the fire, and very nice. This is a very nice Nero actually. Very nice life form and a huge something that looks like Nero, but I'm not certain. So these are really this is a huge Nero, really big one. This is the 64 magnification, which is the minimum that I can use right now with the lenses that I have. More life forms. Smaller Neros. Okay, so this was interesting. Let's take a quick look on the other one. Again, from a couple of days ago, before the electrolysis. The electrolysis was done with the maximum DC transformer that I have, which is about 40 volt or 30 volts, but the mixture was very non-conductive because it was mostly oil material. So, but maybe some ionization actually took place. This is of course a life form. And very interesting life forms. Neros, smaller of the smaller type. all sorts of life forms that are interesting, actually, very interesting. So very interesting life forms of all sorts of shapes. This looks like both like Neros and like life forms, so it's difficult to judge. I don't know what it is. Maybe it's life forms, maybe Neros. Difficult to judge. It looks something in between. Something hybridic. I mean, this is certainly. I mean, I don't know what it is. Is it artificial? Is it mechanical? It is. I don't know. These are Neros and very nice ones, actually. Okay, so this will be it. Now let's take a look. The samples that I've taken just now. It wasn't connected to the electrolysis during the last about 24 hours, but it was for a couple of hours before that. So maybe the ionization should have some effect, and maybe not. Anyway, I've taken 2 samples, so let's take a quick view. Of course, the purpose of electrolysis is not ionization in itself. The purpose is to let the Neros create chains of superconductive material in order for them to be able to work in a very efficient way by harnessing the electrical energy. And this was done many times. I mean, it was documented in a series of very long series of experiments that are documented in this video. I haven't done it for quite a while because, as you know, I'm focused on other things in the past month or two, but it was one of the major issues of this channel was the electrolysis chamber experiments, and there were many dozens of these, and it's all documented and very interesting. So, first of all, what we can see immediately is that you have many Neros here, which is good. In various sizes, and this is good, this is nice, this is good, this is very good. Seems that they were able to, perhaps, I mean, there was some kind of, a closed circuit between the poles, even though the medium was it was of low conductivity, but it was a small, circuit inside. Like, the poles were put like very close to each other inside the. So maybe the Neros created the chains of superconductive materials, because we see a very large amount of Neros, and these are not duds, what I call duds. Duds are what I call Neros that you can see after the creation of Neros using electrolysis. As you can see in many of the experiments, it was typical that create many that were not created like entirely, and after like about several hours they are all like disassembled, like they seem back to the liquid. they disappear. But some of them actually stayed alive. But now this is a long time after we disconnected the circuit, like more than 24 hours. So all of these that you see right now are not duds, but real Neros, which is very good, and they are pretty big, not huge, but pretty big one, and we have large quantities. So this tells me that yes, the Neros did multiply very well using the electrical energy, which is something that we've seen in the past that they can do, and possibly also using the fire energy. I mean, possibly because we also have lightened it, like, I mean, with fire several times. So maybe they also stored the heat energy and they used it, I mean, for the purpose of multiplication, because what we see here is a classical example, I would say, of multiplication using the electrolysis method and not using the ecosystem method, because you don't see almost no life form. You see several life forms here. It's not devoid of life form, but I mean there are many Neros and very small amount of life forms. So it's not like they've eaten the life forms and multiplied, I mean, at their own leisure, like, I mean, that we've seen in the ecosystems experiments from like the various containers, the aquarium containers. What we see here is certainly from experience we can say, and also, I mean, it makes sense that this is an example of multiplication that was done by harnessing an external source of energy, and this external source of energy was first of all was probably, I mean, from experience, I know that it works very well with electrolysis, and that's what we have done for many, I mean, several good hours. But also, we should not forget the fire, which was done like several times, and maybe they harness both the energy from the fire and from electricity. Maybe it's stored as different kind of energies, and they use the both, because we see here, what we definitely see is the result. This is a life form, very interesting one. But what we can definitely see is not that many life forms, even though we see some life forms, but a very large amount of Neros with all sorts of sizes, very big ones, very small ones, and something in between. Fat ones, like, I mean, you know, thin ones, all sorts of like Neros, and I mean, that are in like in distribution and amount that I mean that is the characteristic of multiplication using electrolysis and not by the ecosystem path. So this is very nice, and they are all they are really Nero, not dots, because I mean it's not connected to electricity for like more than 24 hours, and I mean I haven't lightened it in this 24 hours, so there wasn't like kind of like, I mean, a huge start of, I mean, they didn't like started to produce like, I mean, in tremendous like way during the last 24 hours. So the dads already died, I mean, supposedly, and disseminated into the liquid. So what we see here is actually Neros, and in very nice quantity, without that much of life forms, but certainly we do see some life forms that survive the fire. They also survive the electricity, even though it's high voltage, because it's not really that, I mean, because of the low conductivity, I mean, the current was probably very low. I mean, if you want to use electrolysis, high voltage electrolysis to exterminate these life forms, and I've done it in the past, and it was also documented, you need the mixture to be more conductive, and there are all sorts of ways to do it. But I mean, let's just this is not for now. Let's just take a look at another slide, which was taken, another sample that was taken right, I mean, just now, together with the previous sample. See what we can see here. Okay. So again, we see nice Neros, fat, a little more on the fat size, I would say. Little fatter than the ones that we've seen before, and somewhat, I mean, yeah, somewhat fatter, somewhat bigger, and somewhat less than before, but also many of them, and very nice ones. So this is also, I mean, a good, very nice sample. Yeah, certainly, I mean, we see this sample is characterized by on average considerably larger Neros and fatter. When I say fat, I mean that the ring is fat, like as that the ring as in relation to the radius of the whole, like the width of the ring in relation to the radius of the whole circle is larger than like the thin ones. This is all burned material, what you see, most of it. This is a very fat one. This is a very nice one actually. So we can take a quickly zoom in. I don't know. I don't have like the mood for it, but this is a zoom in. Maybe even another one. So okay, you can see flow, which is characterized as slides that were just prepared now. So this is perfectly normal, the flow of liquid. I don't really have the patience to deal with too much, like right now let's just do it in the 64 magnification, and because I want to focus on other stuff. So yes, more Neros. Again, more like on the fatter side, I would say. Not that many as we've seen in the other slide, but certainly fatter on average, and a little bit bigger on average, and certainly fatter on average. I have no idea. What's the difference? What between the fat one and the thinner one? It makes sense. It probably goes without saying that the bigger one, the bigger the radius, the more work they can do. Makes sense. And they are the more energetic and they require more energy. But I'm not sure. What's it? But there is also a difference in width, like in the width relation to this radius. So so like there is like two parameters. These two parameters of size, like both like radius and how fat they are, and I don't know like what's the difference between the fat ones and the thin ones, but I kind of assume that the fat ones are stronger. But I don't really know how to check it, or what parameter can actually be placed for strength. So yes, we see they are demonstrated fatter here than the previous slide, but both slides are very successful. Like we've seen plenty of Neros, and this is all a result of successful implementation of the symbolic language, together with pretty successful energizing of the Neros, both with fire and later with electricity. Okay, so this is it. More Neros. This is the end of the slide. So okay, so that I'm keeping like I'm keeping the container like on the balcony. It's open to the air actually, just with a little cover of like this symbolic language. This is the container, the big one. This is in general, as I said, almost always there is like a smaller one and a bigger one. This is almost always the case with the constructions of the Neros, like on the construction of experiments, like of Neros. So, and they are both made of clay. So both samples were taken from the bigger one, and I'm keeping it like that. Open to the air. Usually, too much air is not good. Too much oxidation is not good for Neros. It kills them. But from experience, I know that if the mixture is very oily, and this one is very oily, it's mostly melted beeswax and canola oil, and also sort of like paper, like cotton that is used for the fire. That is much of it is burned or dipped with oil. If it's very oily, then they survive pretty well, even like when it's open to the air, because it's just just the upper layer is really exposed to oxygen. So I know for experiment that for very oily mediums, you can place it like that, like on like too open to the street, open to the elements. What kind of elements we have in Israel? It's mostly heat. So and also it takes from noises from the neighbors, but I mean, you can place it like that, and even for months, I mean, they will survive pretty well because they just, I mean, hide, I mean, inside the, I mean, under the oil ocean. So I'll keep it like that without cover, and I'll keep it like that for a couple of days, more days. Maybe I will conduct more fires and more electrolysis, but not today. Maybe tomorrow or the day after that, and we'll see what goes. I mean, I'm very satisfied with what we've seen, specifically with the 2 slides that were just taken now, because we really see a good amount of Neros, and they look really healthy, like not duds. I mean, I mentioned the issue of that because it was a major issue when I created the electrolysis experiment in the various metal containers. It was, again, it's documented in the chess channel. It was a huge issue, and many times you see, like, I mean, like many thousands of like new Neros, but I mean, they are not like, I mean, they are not, they are half baked. I mean, they look like Neros, but they look like, I mean, distorted ones. And when you wait a couple of hours after you disconnect the electrolysis, they just like melt into the water. But some stay alive. I mean, but all of these, the ones that we've seen now are all, none of them are duds. They are like real Neros, healthy, and even much fatter than on average, I would say, and pretty big. So yes, this is a quality container, I should say, and we should keep using it. So I mean, this will be all for now. Maybe if I'll have like the energy later tonight, I will conduct another episode of the series of the Ziggurat of Ur. Let me think about it.